All right, so for this next example, we have two fractions. And so these are actually going to be hyperbolas as well, like they're going to look like your 1 over x's if you graph these in Desmos. And so you're trying to figure out where these guys intersect each other. So they look a little bit difficult, but they're actually not that bad. Even though you're working with fractions, it's still a pretty easy problem. So what we're going to do is we are going to make either the x coefficients here, this 2 and 1, the same, or we're going to make this 1 and this 3 the same. It doesn't matter which one you do. So for this particular one, I'll just go ahead and multiply this bottom one by -2, and then we'll eliminate using that. Well, you know what, let's go ahead and multiply this by 3 so that I can just add, and then we'll eliminate your y's that way. So let's do that instead. So we'll multiply this top by 3. When you do that, you'll get 6 over x plus 3 over y equal to 3/5. And then the bottom will remain the same. Now these coefficients are going to be opposites of each other, so I can go ahead and add them. And so when I go to add this, these two pieces will go away. I'll end up with 7 over x. And now I have to add these two fractions. Well, in order to do that, I know I need to get a common denominator. So I'm going to go ahead and multiply both top on this one and bottom by 3 to get 15. And then I'll do, so now I have 9 over 15. What's wrong with me? So this become 9/15. And then when I multiply this one, this will become 5/15. Now I'm just simply adding these. So when I go to add these, I end up with 14/15. And so now in order to solve for x, I'll multiply both sides by x. So I end up with 7 equals 14 over 15x. I'll multiply both sides by 15. By the way, I could have gone ahead and just cross-multiplied this and gotten the same answer. When I multiply both sides by 15, that cancels this, so I'm left with 14x, and now I'm going to divide both sides by 14. Notice I didn't multiply the 15 and the 7 together just yet. I could have, but I'm getting ready to divide by 14, and 7 goes into 14 very nicely. And since these are being multiplied, I can cancel. This become a 1, and this will become a 2. So we end up with that x is equal to 15/2. All right. So now that I know that x is equal to 15/2, I can plug it into one of these. It doesn't matter which one. So let's go ahead and plug it into number 2 here. So I'm going to end up with 1 over 15/2 divided by 15/2 is the same thing as multiplying by its reciprocal, so I really have 1 times 2/15 here. Oops. And now I want to subtract 2/15 from both sides. So that was the same thing as 5/15 minus 2/15. And so I have -3 over y equal to, let's see, -3 over y equals 3 over 15, right? And I can go ahead and cross multiply here. So this becomes 3y, this becomes -45, so I end up with 3y equals -45. Divide both sides by 3, so I end up with y equals -15. So my two answers together become 15 over 2, comma, -15. Easy peasy. Okay, so now that one is done. Last example that we're going to do is using logs. So for this one, you'll notice that your y's are already on the same side, so you don't need to move anything at this point. You could actually go ahead and subtract right now. So we get y minus y, which becomes 0. And then we have this log base 2 of x plus 28. And we're going to subtract, I should have given myself more room here, log base 2 of x, and then subtract 3. Now it's been a little while since we've done logs, So in case you've forgotten your log rules, you have to go back and remember those. So let's just recap logs for just 2 seconds. A few things that we need to remember. So remember log base, let's just pretend 5 of 125. Let's remember that the exponential form of this, if let's say this was equal to y, this is what's called the logarithmic form. The exponential form would be this, 5 raised to the y power equals 125. So logarithmic form, exponential form. And the answer to this y would be the exponent on 5 that gives me 125. So in this case, y would be equal to 3. Okay, that's one of the things that you got to remember, exponential versus logarithmic form. A few other things, we've got some properties that we talked about. So a few of those properties that we have, for example, are when you add 2 logs, it doesn't matter what this base is here. Let's call one of the arguments m. Let's call the other argument n. If you add 2 logs, that's the same thing as multiplying just the arguments. You'll condense it, we call this condensing, into 1 log, and you would multiply just simply those arguments. If you have a subtraction of 2 logs, the idea is the same, except now you condense it, you have 1 single log, but now you're going to divide those arguments. And finally, if you have an argument raised to a power, let's call that power r, it's only on the m, it is not on the log itself. Like for example, there wouldn't be a parentheses here because that would be on the whole log, and so that we couldn't use this property. And so what we can do if it's only like this, where the r is on the m, I can take this r and move it down in front and multiply it as a coefficient with the log m. Okay, so those are all the properties we have to go back and remember. So you'll notice that here we're going to actually be able to use one of those properties. We've got a log here being subtracted and then another log here. So that's what we're going to do, is we're going to use this one right here with the division. But you'll notice there's a 3 in the way. We need to move that 3 out of the way, and we're going to move it to the other side. So we're going to begin by adding 3 to both sides. Now we have a, oh, I just did that wrong. Sorry, that's supposed to be an x. So now we have 2 logs, they have the same base, and we have these arguments and they're being subtracted. So we're going to go ahead and divide those arguments by condensing this into 1 log. And then we have it equal to the 3. Now we're going to turn this into its exponential form using this going from logarithmic to exponential. So this 2 will become the base, 3 will become the exponent, and then we'll have the argument become what it's equal to. So now 2 cubed we know is 8. So we'll have 8 equal to x plus 8 over x. Now in order to solve this, we'll multiply both sides by x. So we have 8x equals x plus 8. And now subtract x from both sides. Make sure I did everything right. Seems to be. So subtract x from both sides, and we end up with x equal to 8/7, it looks like. If I did this correctly, x is equal to 8/7. Let's go back up. I don't know why I made that go down. All right, so now we'll go back into the original problem, and we'll plug that in. It might be easier to plug in the 8/7 here. And so we would end up with y is equal to 3 plus log base 2 of 8/7. I wouldn't expect you to clean that up a little anymore. Let me just make sure I did that right. No, of course I didn't do that right. Oh, because I wrote the original problem down wrong. What the heck is wrong with me? All right, so I'm going to apologize. I somehow, and so hopefully you caught my mistake. I don't know what was wrong with me. So that's my bad. So right here, when I went to write this down, I wrote down x plus 8 instead of 28. So that's my bad. Hopefully you caught that mistake before I did. And so hopefully you did it right. So all of my work as far as the condensing and everything would have been right. The only problem I would have had is right here when I went to go do this part right here. And so this is where my mistake would have been. I would need to subtract x still, and I would get 7x equal to 28, not 8. That's my bad. And then I would divide both sides, and I would get x equals 4. So I apologize for that mistake. And then when we go to plug that back in, that's actually a lot easier to work with. So I should have realized that there was something wrong with that. So right here, if I plug in 4 now for my x, this is asking you 2 to what power gives you 4. That answer is 2. 2 plus 3 is 5. So our answer then is going to be 4, 5. And that'll do it for this PowerPoint.